Hi class, and welcome to today's lesson. Today's lesson will be on prime factorization, and our essential question for this chapter is what strategies can be used to multiply whole numbers. So we want to keep this question in mind as we go throughout the lesson. To start with, we need to know if a number is prime. And in order to know if a number is prime, we need to know the factors of that number. Remember that factors are any two numbers that you multiply together to get another number. For example, 4 times 8 is 32. So the factors of 32 are 4 and 8. So 32 has two factors of 4 and 8. A prime number is any number that has exactly two factors, and those two factors are usually 1 and itself. For example, the number 5. The only two numbers you can multiply together to get 5 are 5 and 1. However, if we look at 6, 6 is a composite number. It's the opposite of prime, which means it has more than two factors. So to get 6, we can multiply 6 times 1, and we can also multiply 3 times 2. So prime numbers, there's only two numbers that you can multiply together to get that number, and those numbers are 1 and whatever number we're multiplying. 2 is a really interesting number because the only way we can get 2 is to multiply 2 times 1. Which means that 2 is the only prime number that is also even. All other even numbers like 4 and 6 have more than two sets of factors. So 4 we can multiply 4 times 1, or we could also multiply 4 times 4. So 2 is a very special number because it's the only even prime number. So today we're going to be looking at prime factorization, and prime factorization is when you take a number and you write all the factors of that number until they are all prime. So let's look at an example. Example 1. Mr. Dempsey surveyed his class and found that his students have a total of 36 pets. Find the prime factorization of 36. So in order to do this, we're going to use what is called a factor tree. And if you look at this diagram right here, it kind of does look like an actual tree. So that's why it's called a factor tree. So on our factor tree, we're going to put the number that we're trying to factor is 36. And in the directions it says find the prime factorization of 36. So we're going to be factoring 36. So it goes at the top. The next step, step number 2, choose any pair of whole number factors of 36. So we can choose any two numbers that we multiply together to get 36. So our first one, 2, we can do 2 and 18 because 2 times 18 is 36. We can do the same thing with 3. So we can do the same thing with 3, and we can multiply 3 times 12, and that also equals 36. So we're going to continue to factor any number that is not prime. And like we said earlier, 2 is a prime number, so it's done being factored. But 18 is not. 18 is composite, so we can factor that again. And we know that 18 is 2 times 9. And 2 is prime, so we're just going to bring it straight down. It can't be factored anymore. So we have 2 times 2. And the 9, even though it's odd, is a composite number because we can multiply 3 times 3 together to get 9. We can do the same thing with our factor tree over here. We have 3 and 12. So we're going to factor 12. 3 is prime because the only way we can get 3 is multiplying 3 by 1. 12 is composite. Remember, that's the opposite of prime. So there's more than one way we can get 12. So we're going to pick any two factors of 12. So I'm going to pick 2 and 6. And we see here that 2 is prime, so just like we did with the 3, we can just bring it straight down. It's done being factored. Then we go to our 6, and we have to think, what are 2 numbers I can multiply together to get 6? And those numbers are 2 and 3. So then you're going to take your prime factors and you're going to write them in order from least to greatest. If you look at this prime factorization and this prime factorization, we have the same numbers in each prime factorization: 2, 2, 3, and 3, 2, 2, 3, and 3. It's just the order that's been switched. So to write the prime factorization, we're going to write them in order from least to greatest. So 2 was our first one. Then we have another 2, another 3, and another 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. And one way that we can check this is to work backwards. And if we've done it right when we multiply 2 times 2 times 3 times 3 in order from left to right, your answer should be the number that you started with. So let's try that up over here. We have 2 times 2 times 3 times 3. Well, I know that 2 times 2 is 4, so now I have 4 times 3 times 3. And now I can multiply my 3 times 3, which is 9. So now I have 4 times 9, and 4 times 9 is 36, which is the number that we started with. So we know that our prime factorization of 36 is correct. All right, let's look at example 2. In example 2, we're finding the prime factorization of 24. And as it says in number 1, you can choose any pair of whole number factors. So there are lots of different ways that we can get 24. We can multiply 3 times 8, 4 times 6, or even 2 times 12. And we could use any of these sets of factors to find the prime factorization of 24. In this example, they've already chosen for us. They've chosen 3. So we're going to use the factor pair of 3 and 8, because we know that 3 times 8 is 24. 3 is prime, so we're just going to continue to bring it right on down. And then we have to factorize. We have to factor our 8. And so we can choose any 2 numbers that we multiply together to get 8. So we're going to choose 4 and 2. So we're going to choose 4 and 2. And we already know that our 3 is prime and we brought it down, so we're just going to continue to bring it on down. Our 2 is also prime, so we're going to bring it down. So we have 3 times 2, and then we have to factor our 4. So we're going to choose 2 numbers that we multiply together to get 4, and we're using any number that is not prime. So we wouldn't want to use 4 and 1 because 1 is a prime number. So we're going to choose the factors that we wouldn't want to use 4 and 1 because we've already used 4 up here. So we're going to choose 2 other factors of 4, which are 2 and 2. So then the last step, step number 3, is to write the prime factors in order from least to greatest. So we have 1, 2, 3. We're going to multiply 2 3 times, and then we have a 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. And like I said earlier, to check, we can work backwards. We can multiply all the factors in order from left to right, and then our answer should be the same number that we started with. So if we took 2 times 2 times 2 times 3, we could do 2 times 2, which is 4, and 2 times 3, which is 6, and multiply 4 times 6, which is 24, and that's the number that we started with up here, so we know that our answer is right. All right, let's look at our guided practice. Our guided practice says to find the prime factorization of 16. And once again, they've chosen one factor for us, so we need to find the missing. So what number do I multiply together with 2 to get 16? Well, I know that 2 times 8 is 16, so I'm going to write 8 in this box. 2 is our prime number, so we are done factoring it, and we can bring it straight down. Then we're left with our 8. So now I'm going to think, what 2 numbers can I multiply together to get 8? And I know that 2 times 4 is 8. So now I have 2 times 2 times 4. This 2 is prime, so we're going to bring it straight down. this 2 is prime, so we're going to bring it straight down, and we're left with factoring the 4. Well, we know that 2 times 2 is 4. So the prime factorization of 16 is 2 times 2 times 2 times 2. Thank you for listening to today's lesson, and don't forget to complete your independent practice before meeting with the teacher.